During your cross-country flying, you've probably seen some large pressure changes as you flew from one area to another. Ones that move the hands on your altimeter noticeably when you entered a new altimeter setting. Well, as you already know, when you're flying cross-country IFR, ATC will give you the current local altimeter setting for each area. This helps make sure you're at the proper altitude for traffic avoidance and terrain separation. That current setting is important because below 18,000 feet, the IFR and VFR altitudes only have 500 feet of separation between them. Now, 500 feet of separation may seem like a lot, but consider this. Since there's approximately 1,000 feet of altitude change for each 1-inch change in pressure, your altimeter setting only has to be a ½ inch off for you to be at a VFR altitude instead of an IFR one. For example, suppose you have an assigned altitude of 8,000 feet, and the controller gives you a new altimeter setting of 30.15, but you get distracted and forget to put it in. You keep 29.65 in your altimeter window instead. The difference between the settings is 1/2 inch, which means you are now off your assigned altitude by 1/2 of 1,000 feet or 500 feet. To know what happens to your airplane, you can use the memory phrase, "From low to high, clear the sky." You've moved from an area of lower pressure to one of higher pressure without resetting your altimeter. So your airplane will be higher than it should be. Your airplane is now 500 feet too high, which in this case puts you at 8,500 feet, a VFR altitude. Now, if you're in the clouds where everyone is IFR, you have an extra cushion of separation because IFR altitudes are 1,000 feet apart. So to put you at risk of a collision due to altimeter setting errors, both you and some other IFR pilot would have to be at least ½ inch off on your altimeter settings, one high and one low, which is a very unlikely situation. But the way you make sure you keep the maximum separation is by flying on your assigned altitude and using the correct altimeter setting. Since ATC is invested in keeping airplanes separated by their altitudes, they usually issue altimeter settings before you can ask for them. En route, they'll normally give you the local altimeter setting when you check in with each new sector. In the terminal area, if you have not confirmed that you have received the current ATIS, ATC will give you the current altimeter setting for your arrival airport. As you remember, Class Alpha airspace is at and above 18,000 feet. And up there, you use the standard altimeter setting of 29.92 and fly at flight levels, which are also pressure altitudes because your altimeter is set to 29.92. If you're flying in Class Alpha airspace, you'll be given the local altimeter setting when you're cleared to descend below the lowest usable flight level. Now, when you're flying an instrument approach, a properly set altimeter is the key for a safe approach in marginal weather. Let's look at what will happen if you forget to reset your altimeter before you flew the ILS runway 12 approach into Tri-State Airport at Huntington, West Virginia. Suppose, for example, your en route altimeter setting was 29.98. You listen to the Tri-State ATIS and hear that the altimeter is 29.89. But you forget to enter that setting. How much is your altimeter off? When you subtract 29.89 from 29.98, you get a difference of 0.09. If you multiply 0.09 times 1,000, you get 90 feet of error. Since you've gone from a higher pressure to a lower one, the saying is, from high to low, look out below. In this case, you are 90 feet lower than your altimeter indicates. Not good, since your obstacle clearance on final using a precision approach could be as low as 150 feet. But you have a chance to catch your error after you intercept the glide slope by Checking your altitude at the locator outer marker. If you're on glide slope, when you cross the LOM and your altimeter is set correctly, your altimeter should read 2,262 feet MSL. In this case, because you do not have the correct altimeter setting in the window, you'll probably see something like 2,350 instead of the 2,262 shown here on the chart. And that should be a red flag telling you to recheck your altimeter setting with ATC or the ATIS. But if you do not reset the altimeter and continue your descent until your altimeter indicates 1,028 feet, the decision height, you will actually be at 938 feet MSL. What does that mean to you? Well, you are 90 feet closer to the ground and somewhat closer to the runway than you should be at the missed approach point. Plus, you will not have standard obstruction clearance for doing the missed approach procedure. And that's how airplanes get mixed up with tree branches and antennas. Notice these obstructions in the missed approach area, especially this one near the runway that goes up to 925 feet. That's just the kind of thing that could be a real problem for you with a misset altimeter. Now, your altimeter has errors due to temperature changes as well as pressure changes. Like some human physiques, our atmosphere has bulges and depressions. When the air gets hot, it expands and the column of air gets taller. And when the air cools off, well, it shrinks and the whole column of air gets shorter. What does that mean to you? Well, when you're flying along at a constant indicated altitude, your altimeter is measuring a constant pressure. Another way to put it is, your altimeter is measuring what percentage of the way up you are in the column of air. But as that column of air cools and gets squattier or heats up and stretches, your actual true altitude above sea level goes down and up. As you can see, these temperature changes work the same direction as the pressure changes. High to low, look out below. If the temperature is colder than standard, you will be at too low an altitude. And low to high, clear the sky. If the temperature is warmer than standard, your airplane's true altitude will be too high. Now, unlike for pressure changes, there is no adjustment in the altimeter for these temperature changes. But since the altimeter errors are based on the shrinking and expanding of the air above the reporting station, the closer you are to the altitude of the reporting station, the less the errors are. In fact, when you're on the ground at the reporting station with the current reported altimeter setting in your altimeter will read accurately. Since as you get closer to the reporting station, the altimeter errors are lessened, they really aren't much of a problem for approaches. But as you climb to higher altitudes in the non-standard air above, the altimeter error increases. In reality, the only case in which errors in the altimeter due to non-standard temperatures are a problem is when you are flying in the mountains high above the reporting station. Now, here's an interesting, although somewhat rare situation. Sometimes you can have extremely high pressures associated with extremely low temperatures. You're most likely to find this situation in places like Alaska and northern Canada in the winter. In some cases, the pressure can be over 31 inches. The problem is that normally the highest setting your altimeter can accept is 31.00 inches. When that happens, the FAA will issue a NOTAM, which describes the area of extremely high pressure and tells you the procedures to use. It's not something you're likely to see, but if you ever do, just study the NOTAM to find the procedures for safe IFR flight in that area. So as you can see, although your altimeter is affected by non-standard conditions in the atmosphere, if you update it throughout your IFR flight with the current altimeter setting, you will help ensure that it gives you reliable and safe indications.